let's add references to a project. In this case, we're going to use a Windows application, and we'll add three references, three different kinds of references to this project. The three kind of references are file references, project references, and shared project references. And each of these is going to behave just a little bit differently. Let's go ahead and add them and see what that looks like. So we have here a Windows application. It's pretty simple. It just has basically a bunch of labels on it. So for each of the historical dates that we have here, we're going to get that information from a property inside a class that's inside of a project. And that project will either be a library project or it'll be a shared project. And we'll see the difference there. So the first one is going to be a file reference. So let's create a library. And what I'm looking for here is a standard library. Now this doesn't have to be a standard library. It could be, we could use some of the other frameworks instead, but it just makes the most sense to make it a standard library so that it's as usable across as many platforms as possible. So we'll call this one Demo Roman Library. And in that library I will put or create a class called Caesar. And in that class, I will put a property. So in this case, I'm using the lambda syntax. So what you see here is lambda syntax for a read-only property. So what that means is that this property will return this string. That's all it could possibly do. So this is basically another way to create a constant, but as a property as opposed to a field. And now I want to build this library. And once I've built it, I will be able to use it as a reference in my Windows application. That's here. We'll then add a reference. So as I said before, there are three kinds of references, and the first kind of reference we're going to create is a file reference. And typically the way you're going to create a file reference is to browse for the DLL file that you're creating a reference to. So I could click here on Browse, or I could just go to the Browse button. So there's my demo Roman library.dll file, and I'll click Add. And OK. And now if I look at my project, you can see there's now a reference in my references area, Demo Roman Library. Makes sense. All right, let's create another library. This will also be a .NET Standard library, but we will create the references slightly differently. And once again, I will put a class inside of it with a property. And I will use that same kind of property syntax. All right, now that we have created this library, we'll go ahead and build that project. And going back to our Windows project, we will add that reference. But this time, rather than searching for a file, we'll go up here to Projects, and we will find the library that we want to create a reference to. And here it is. And notice that this is a project reference as opposed to a file reference. So in other words, any of the projects that are in a given solution can be connected together using a project reference. And now we can see that we have a reference to the Demo Japanese library here. Now before we actually make use of these libraries, let's go ahead and take a look at them in the object browser. So for each of these references, and of course you could have done this from the library project itself, I can right-click and say View in Object Browser. And here's the Roman library, and I will open that up. And the namespace Demo Roman Library, and the class Caesar. And then over here we see the property associated with that particular class. So remember the namespace Demo Roman Library. We go back to our Windows application, and let's create a field. So there's the namespace followed by the class, and I will instantiate that object like so. And that will allow me to get information from that object. So I'll assign that to a text field, and now the value of the text property for that particular label will be filled in. I can do the same thing for the Japanese date and assign that to the Japanese label. And we can see the effects of this by running the code. And there you see now that the Julius Caesar assassinated date is the Ides of March, and Japan becomes a country, is the Japanese information about that date. So now the question becomes, what exactly is the difference between a file reference, which is where we got the Ides of March, and a project reference, which is where we got this Japanese date? And the answer to that has to do with how they're updated. So let's close this and go back to each of the libraries, and we'll change the definition of assassinated to something that's true but expresses the date in a little bit different fashion. And along the same lines, let's look at the Japanese information and make a modification to it. Now we will once again, without rebuilding anything, run the Windows application. And now we can see the difference between a file reference and a project reference. With the file reference, because we're pointing to an individual file specifically, and I didn't rebuild that library, the Roman library, we're still seeing what effectively is the stale value of the date. On the other hand, because the Japanese library was a project reference as opposed to a file reference, we see that it has automatically been built as the Windows application itself was built when I clicked on Start. So that's the difference between a file reference and a project reference. With a project reference, you don't have to go and rebuild the library every time. It automatically gets rebuilt every time you rebuild the project that actually contained the reference, which in this case was a WinForm application. So that leaves us then with the shared project. Let's take a look at that. So I will add a new project, and this time, rather than a library, I will create a shared project. And as you can see, the shared project is not actually a library, it is literally a shared project. So in other words, as opposed to a library which you connect to with a reference at link time, with a shared project you're actually connecting at compile time. And that's going to have a couple of effects. Let's take a look. Okay, so there is a class with a property inside it, and this code will be compiled together with my Windows application project as soon as I create a reference for this shared project. So let's go back to the Windows application project and add that reference. And you'll see here under shared projects, there is my shared project. And I click OK. Then I go back to my Windows application and create another field and use that object to modify the label. And run the code. And as you can see, I have new values here, specifically this value. If I were to update the value in the shared project, that change would actually take place when the Windows application is recompiled or rerun. So let's make that change and simply rerun the Windows application, and you will see that we get a new date in here without explicitly rebuilding the shared project. In fact, let's take a look at rebuilding the shared project. So here's the shared project, right click, and you'll see that rebuild isn't even on this context menu. It's not actually possible to separately compile this because by definition a shared project is compiled when the project that's referring to it is recompiled or rebuilt. So in effect, the shared project is behaving the same way as the project reference, but here's how they're different. Because these are compiled together, we could, for example, change the access specifier of this property. We can do something, for example, like this. We can make this field internal. Now the definition of internal is essentially public to the project. In other words, if a field is internal, it's available to other classes in the same project. But a shared project is effectively the same as being in the same project. So I can rerun the code and this will still work. And as you see here, we get that date, just as we did before. If I were, for example, to change either one of these fields into being an internal field, the code would no longer compile. Let's take a look at that. So for example, my Japanese library, I'd made that public so I could use that property. If I change this to internal and then go back to my Windows application, I will see that that field is no longer available because it's internal to the library project. But because a shared project is effectively in the same project, I do have that access. So again, there's three types of references. There's the file reference, and that's the most static. And in order for you to see the changes in the library with a file reference, you have to manually rebuild the library. There's the project reference, and project reference means that you've got two projects, one references the other. Those projects are both in the same solution. So if you make a change to the library, you don't have to manually rebuild the library to see that change. And the third is the shared project, which isn't even a library. It's sort of a compile time library, if you like to think of it that way. And it is actually compiled into the project that refers to it, and so has a certain amount of special access. And then lastly, of course, we might want to use using directives. These names here are using directives, so if I wanted to shorten these names, those are my using directives, and now I can remove the namespaces. And I'll go ahead and fix the problem with the Japanese date so it all works. Put that back to public, rerun the code, and everything works as expected. Except, of course, for my file reference. So now let's go ahead and manually rebuild that library. And I run the Windows application. And all the dates have been updated, as you see here. So that's references to a project in C#.